Hello, I'm Tim, and I currently work at Dell Networking. This particular talk has its roots from when I was at a group in EMC, and at the time, this is about 6 or 7 years ago, we were operating a medium-sized cloud object store. So we stored whatever you sent us, right? And it was a traditional network environment with a core and distribution layer and operated in a very traditional format, all CLI driven, no automation of any kind involved really in the process. And we were asked to expand the environment significantly. So we went from operating this medium-sized cloud with, let's say, hundreds of switches to having to build out a very large environment that was measured in thousands of switches, and also went from storing, petabytes of data to storing exabytes of data. So a significant jump in what we were asked to do. And when we started in this process, this was fairly early, at least for us, and I think even in the community, as far as DevOps methodology and how that applies to networking. Obviously, our friends over on the compute side and the storage side have been doing this for decades, and they all look at us and laugh. But for us, this is quite new. And so we had started experimenting with the idea of bootstrapping equipment using some form of automation. We went to a Cisco Live conference, and we heard about POPE, the Power On Auto Provision methodology that Cisco has, and started experimenting with that along with Puppet, something that we knew, right? And in that process, we found there's a problem with that, right? And what do we do about how we get data in, right? So how do we get data into the automation process? Where do we store this data? How do we collect it? How do we actually begin the automation? So that's what this is about, right? A single source of truth for your automation. The dream. We want to click the easy button and the network's configured, right? Like we want to just have it all happen, right? We don't want to have minimal human involvement, hopefully, right? Like this should not be something that network engineers are having to sit and do and copy paste or what have you. Of course, that's the dream, right? The reality, not so much. Right? We have varying vendor support for various methods of automation. There's multiple completing frameworks to use for your automation. Nothing's off the shelf. There simply is no easy button that helps you create the easy button, right? This is something that traditionally had to be custom built. Why do we want to automate? This is a question that sometimes comes up, and I think particularly if you're making the transition from more traditional operation model to an automated or DevOps model, often we ask this, right? And quite often people make the transition due to scale. Because you simply can no longer hire enough people to do whatever the work is. Sometimes people think the reason we might want to do this is to save time or save money or various other reasons. And really, no. The reason we do this, at least for us, is item potency. So it's a term we stole from, or DevOps stole from the math academic wonks. And it just is essentially the idea of that we should be able to repeat a task and get exactly the same result every single time. So we should be able to burn our data center to the ground and redeploy it tomorrow, and it should look exactly the same tomorrow as it did today. So there should be no difference in every time we run this task, we should get the same result. That's the primary driver behind automation and DevOps culture. And this is something I think, it's a bit of a paradigm shift, right? Like we have to think about how we do things in a different way. And this is a key component of that. Automation versus orchestration. What are those two things? Orchestration, codifying your process. So taking your process flow, your workflow, and putting that into code form. Automation, codifying your tasks. So these are individual tasks that we take that a human used to do, and we make code do it. So these two things go together, but they're not the same. And it's a key thing to think about, that we need to make sure that we're thinking of orchestration versus automation and how those two things work together. So orchestration, taking our bits of automation and stringing them together into a workflow. So kind of an overview of things that we thought about that we wanted to accomplish when we started down this road of network automation and what does it mean. So we had the bootstrap, right, the greenfield environment, or it could even be into a brownfield environment where you're deploying new gear. We want to deploy the new equipment with minimal human involvement, right? We want to be able to validate our physical infrastructure. So we wanted to be able to automate our cable validation as an example as part of this process. Moving into more of the operations environment, we want our NOC to be able to push out moves, adds, and changes without requiring intervention or work for the network engineering team. Standardized changes should be able to be done without much human or any human involvement. Device configuration. We wanted to be able to take the configs that we had on our devices and templatize it, right? So most likely, the config that's on one spine looks really, really similar to the config that's on another spine. Same for your leafs or what have you, right? So let's put those in template form so we can store them in some format that is repeatable. And it could be in whole for the device or just a part of the device. For example, we had some environments where we kind of thought of the config as two separate components. One that's sort of like the infrastructure component that's a little bit more handcrafted, and then another one that's maybe our tenant-based configurations. So the configurations we need to deploy for particular tenants or customers or what have you, that's probably a lot more standardized and can be easily templatized. And then version control. We wanted to be able to have some form of control over our changes. So keeping our templates in GitHub and then using either branches or forks, depending on your particular religion, as far as how you wanted to maintain your GitHub. And then having a standardized format of peer review before we merge changes up into our master branch. Some tools we looked at. So when we started on this, it was relatively early days, and Puppet was kind of the thing. So that's where we started. Along the way, we experimented with Salt and Napalm before eventually ending up on Ansible. They have their pluses and minuses. I think the simplicity of Ansible it gives it a strong use case in the network world. And on the orchestration side, we have Stackstorm is the one that we particularly went with. Of course, there's also other choices like Rundeck. There are other orchestration tools as well, depending on what you particularly like to use or what works in your case. And as we looked at this, there are some methods of inputting data, right? So we got the really bad, do it by hand, copy paste. This is where we started and is what motivated us to begin this process of so we need a better way to get the data in, right? Because copy paste is very error prone, it's highly time consuming, and it's taking us a long time. Statically defining it in code, also really, really bad, right? That doesn't scale, you can't change it easily. Still not so great. Using spreadsheets, things like Google Docs or what have you. We did this also. This was a step better than doing it by hand, but still error prone and still not particularly scalable. And then finally, a little bit better, but still not as good as it could be, disconnected tools. Things like IPAM, CMDB, DCIM, right? So you have all of these various databases that are generally not connected and traditionally have not been. So the data that's in your IPAM is in no way connected to the data that's in your CMDB or your DCIM. And typically that often means now we're duplicating data. So we've got to put things in twice. We've got to enter the same device into our IPAM that we have to enter into our CMDB. And there's this whole problem of keeping everything in sync, right? Because once you put some data in two places, probably you're not going to have it the same in both. And this leads to lots of problems as we move down the road. So a better way. Let's have a single source of truth for all of our data. Store all of the static data that we have in the database or in the data center in a single database. This lets us link together formally disconnected pieces of data, and we only have to maintain one copy. So instead of having all of these different databases that have no connection to each other, let's put all the data in one. What data do we want to store? So for us, we wanted to store everything. And by everything, we meant literally everything in the data center. It didn't matter whether it was a network piece of equipment or a compute, a server, or something from the storage team, a rack, a tile in the data center, the physical location of the data center. Everything, both physical and logical, we wanted to maintain in the data center. So all physical and virtual devices, we want to put in there. And again, it doesn't matter whether it's a VM or a switch. We wanted to have it in the database. Our links, all of our links going between the gear, data center info, so the site addresses, the racks, etc., IP addresses, VLANs, ASNs, everything. All the bits of data that we need to make our configurations and our environment work, we want to maintain in the database. So as I mentioned earlier, now we can make these rich connections between this data that we have. So now our IP address scheme is linked to our devices that we actually have in the database, et cetera, right? All of our links are connected. We can make connections between the logical side of our link connections, so whether it's the VLAN or the IP address on a point-to-point link, and the actual physical link. So we have that relationship now between the physical and the virtual and logical resources. We can easily retrieve values out of the database based on any number of search criteria that we want. So whether it's a VLAN or what have you. And we can take those resources and put them into pools. So now instead of thinking of, as an example, the rack units in a rack as individual units, we can think of them as a resource pool that can be allocated out. So we can assign out use 1 through 15 to the server team, and we can leave some blank in the middle, and we can give ourselves, let's say, 35 to 48 up at the top. And then we can allocate and let the server team handle the use that they want to take, and we can take ours as well, from the database. So a little aside. Most of us, many of us have a pet, and the characteristic thing about pets, right, is that we love them. We name them, we take care of them, and we particularly are invested in them as an individual. On the other hand, if we look at cattle, and many of you may have heard this explanation before, the pets versus cattle. With cattle, it's not so much, right? We don't care about them on an individual basis. We don't name them. They get some sort of a serial number or a barcode or something. We don't particularly love them on an individual basis, even though we might enjoy them at dinner. And when they get sick, we probably don't really take care of them much, right? We shoot them in the head and we get a new one. And this is, in a way, the way we need to think about our resources. Our resources, we think that they're special. We want to name our switch, we want to love it, we want to pet it, we want to take care of it. When it gets sick, we call TAC and we get it taken care of. And that's how we traditionally have thought about all of our resources, right? We do the same thing with our IP addresses and our VLANs. Like, we care about them on an individual basis. We want to know what VLAN 100 is and that it's going to be the same everywhere and that it has a special name. And the answer to that is, no, your resources are not special. Treat them like cattle. Don't treat them like pets. They're not pets. They shouldn't be something that you love and care for forever. Right? Treat all your resources, and it doesn't matter what it is, whether it's a switch, a server, a VM, treat them as cattle. This allows you and frees you from that restriction of having to care about all the things. Okay, that's the end of my little soapbox speech on that. So, some different examples that you might use as a source of truth. DIY route, right? You could go with a Mongo database or a Postgres. When we started, we happened to have access to a Postgres engineer, so that's the route that we went. You could use something a little more proprietary like PuppetDB or Hiera. And then even just something more flat file like a YAML or JSON file. Relatively easy, but you kind of get back to that data entry problem I was talking about earlier if you go that route. And then off the shelf. So this was an interesting experience for us. When we started down this path, Netbox was not a thing, or it wasn't open source, sorry. It may have existed. And so I think about 3 years after we had been using our proprietary one that we built, we saw Netbox be open sourced. And we saw that someone else had seen the same problem we saw and went about solving it in virtually the same way and did almost exactly the same thing that we did. So it was fun to see that, like, in a vacuum, two separate groups of people created almost identically the same thing. So if you haven't been using Netbox, or if you are using Netbox, this is a great route, especially if you're starting fresh today. Someone's done a lot of the work already, and you may need to make some updates for your particular environment, but this is a great starting point if you don't want to go the total custom path. This is just a simple idea of the kind of data and the way you might format it in your database. As a network engineers, maybe we traditionally haven't thought in this form of DB schema. And so this was kind of new for us, and also was fortunate again that we had a Postgres engineer to help us kind of like learn how to think about how do you format data in a database. And this would be one of the areas where using Netbox might kind of free you up because you don't have to think about this detail because they've done it for you. But if you take what we looked at, and again, this is a fairly sanitized version. This doesn't have all the things, but just to give you an idea. In the middle is the devices, right? And that's kind of the center of the universe. That's where we kind of revolve everything around the device. And again, that device could be a switch, it could be a server, it could be a VM, it could be a rack in the data center. It could be anything physical or virtual in the data center that we want to track in the database. And these are just some example bits of information you might want to store about that device. One thing you'll notice is that we split off interfaces into its own table. And the reason for that is that if you're using different vendors for your equipment in the data center, typically the interfaces are often named or numbered in different formats. And this can be true even within the same vendor, right? Like a particular model might have one numbering format versus another numbering format. And if you're operating in a traditional CLI format, that's not so much of a problem because as the engineer, you know it's E1/1/1 versus E1, depending on the numbering format. But when you move into an automated format, that starts to become an issue. The code doesn't know that those are maybe the same thing. So by having interfaces in its own table, it gave us the freedom to templatize what different models look like and what different vendors, how they number ports. And so you can start to standardize that. Left side of the screen is the physical world. So the site, the rack that the gear is located in, and the physical link connections that occur between the gear. And the right side of the screen is the logical world. So we have VLANs, networks or IP addresses, VRFs, et cetera, right? So these two kind of sides here is how I've tried to present it. And this is just, again, an example of what you might do with your database and some types of data that you might want to store. Hopefully this gives you an idea of some way, if you're not doing it now, that you might think about doing it. So let's take a look at a practical example of what you could actually do if you had a single source of truth storing your data for your environment. And we'll do a little bit of like pseudo code, just kind of give you an idea of how we might actually implement it in the real world. So let's say we wanted to deploy a network update to configure a new physical server that's going to run some web servers. Okay? So we need to know on the physical side, we need to know things like the switch ports that the server is going to be connected to on the two TORs, right? And we need to know what the cabling requirements are. We also need to know like the rack that it's going to go in. I didn't put that up there, but and we've got some logical requirements. Maybe we need a VLAN and some IP addresses and an FQDN to assign out. So from the resource pools that you can now create in your single source of truth, we can programmatically allocate all this data, which if you looked at the previous screen, traditionally, a network engineer would have often, or maybe even still is, allocating almost all of that data out by hand or from a spreadsheet or going to those various different databases, maybe going into IPAM, going into the CMDB, and doing all these allocations, right, by hand. But now we can do that via programmatically. So we can get our rack unit location, we can get our switch ports, we can get our VLANs, we can get our IP addresses, we can do all that automatically. Nobody needs to be involved in that, in that particular process from a human perspective. We can automatically generate the requests going out to DC ops to rack and cable the server. So we can send off a ticket into our ticketing system to have them go do this with all the information they need to do their job, right? So we can send them the cut sheet, we can send them all the port requirements, we can send them the cable requirements. This could all happen automatically. We can generate our network configuration. So we can configure the, we can generate the configuration that needs to be applied to the switches and potentially to firewalls or what have you. We could create some DNS entries. This was an example of something that was, you build something and then people use it in unexpected ways. For us, we created this database that we started using on the network side, and we gradually, just sort of through grassroots underground effort, got the rest of the teams to start using it. And our DNS team ended up creating their own platform that they were monitoring the database, looking for devices and FQDNs that were added to the database, and then automatically populating that into DNS. So they took this platform and ran with it and did their own thing. And it was really cool to see somebody using something we built in a way totally unexpected, that we didn't ever plan for that. So this is one of these things, particularly when you build this kind of thing, other teams will start to see the advantages of it and use it, starts to become a critical tool. The path that we ended up on eventually was Ansible and Python, right, for our automation. Ansible has really short learning curve. Like I mentioned earlier, we started with Puppet. It's kind of like a medium-sized learning curve. It's a little bit harder. Also, particularly comparing those two, one of the advantages of Ansible is that it is agentless, which I think particularly in the network world makes it much easier. Even though today we do now have, generally speaking, access to the underlying operating system on the gear. Back in the old days, we didn't always. It's open sourced, so we can see the changes that are coming in there, and we get pretty rapid updates into Ansible, and really broad vendor support, right? Like Ansible has modules for virtually every bit of network gear or server gear out there. On the other side, on the coding side, Python, most common language, probably. Who knows, right? Like, just depends on your religion again. It's highly readable. So this is advantageous, particularly as people come and go or various people are contributing to the code that we're writing. It's pretty human readable, even though we all should be commenting our code. We don't always. And it's supported in virtually all tools. I think pretty much every major network switch now has a Python interpreter on it. So if you want to run Python on the switch itself, that's a possibility. Continuing down the Ansible path, there's something that is maybe not particularly obvious, that when you're using Ansible, there is a very special place that you can put code that will become accessible to you in your playbooks or your templates. So if you put code in a folder, the Ansible/play/filter plugins, you can access that code inside of your templates or your plays. For me, at least, this wasn't particularly obvious and something I had to kind of stumble on. But it particularly unlocks the possibility of using your single source of truth. Because now we can create a Python code or whatever code you want in this folder that knows how to access your database, whether you're using Netbox or what have you, right? So you can write a Python class or a Python function in there. So this would be an example of a Jinja template. Hopefully, if you are familiar with Ansible or Jinja templating, this would just be a really simple switch configuration, right? We're going to create an interface. We don't know the number yet because we're going to pull it out of the database and assign a VLAN to that interface. So if we take a look at the little bit of code that's there, you'll see we're going to input the FQDN, that's the variable. And we're going to run a function that we've created up in our filter plugins folder called allocate port. And we're going to feed it the pool that we want to get the port from. And that's just, in this case, it's the web server pool. And the same with the VLAN. We're going to feed in the variable of the site. And we're going to run a function called getVLAN and have the same pool web servers for the VLAN. Little nuance of Jinja that's kind of maybe a little different. The first variable fed into the function comes before the pipe. All second and following variables fed into the function come within the parentheses. would be kind of a more normal format. So just some weird idiosyncrasy of Jinja. So this is what we could put in the myfunctions Python code up in the filters plugin folder. Obviously, this is Pseudo Code because I don't know what your database looks like or how you would access it. You would have to write your own class for that. But this would be the basic idea, right? We write a little function that's going to go, that knows how to go look up in the database, feed in the FQDN and the pool we want to get a port from, and return that to the template. And the same with the VLAN. So now down in the play, and again, if you're familiar with Ansible plays, this is a fairly simple one. We're going to actually create the variables that are starting this whole process, right? So we've got the FQDN that we're naming the server and the particular site location. So those will be the variables that are entered into the functions. And then the source will be our Jinja template and the destination will be our switch config. So Ansible will take over. We'll run the Python code that we've written. We'll extract that information out of the database, put it in, merge that in with the Jinja template, and produce our switch config, which will hopefully look something like this. So we got a port back from the database, port 12 is available, and VLAN 101 is free. And so that's what we're going to use to configure these ports on the switch. So looking at kind of like the overview of what just happened and what we could do with that. We can take the automation that we just created, that tiny little piece of automation, and we can layer orchestration on top of that to do more things. So for example, we could take a snapshot of the switch before we deploy this change. We could deploy the change via SSH or API. Ansible supports multiple methods for doing that. We obviously can save the change to the device. And we potentially could roll back on failure from that snapshot we took before. And this would all be layers of orchestration that Ansible could empower for us. If we layered on top of that more orchestration, like a tool like StackStorm or Rundeck, we can potentially do more things. Like, for example, we could deploy this change out to multiple switches at the same time. We could ensure that the change goes through change control properly before it's actually deployed. And maybe we want to automatically deploy the change at 3 a.m. during our change window versus doing it now. We can also make sure that this is triggered by events. Potentially, maybe we want to wait until the DC Ops team reports back that the cabling is done, and then we deploy the change out, right? There are various ways, depending on your environment, that you could run with this and take the orchestration, the automation you created and orchestrate that to do really powerful things. So this is your early warning that we're coming to the end. If you have questions, you can start to prepare them. Network automation, it's becoming mainstream. This is something that we're doing more and more. Hopefully, I don't know where you are in your company, whether or not you have a DevOps culture, but if it's something you've been thinking about, I hope I can encourage you to start to play with it and start to learn about it. If you're not writing code now, please start practicing. Start learning Python or some language, any language. I personally started on Ruby, but wherever you want to, wherever you go. We have to start thinking about things differently. This does require a paradigm shift. It is a whole new way of thinking compared to how we have traditionally operated our networks. If you are just starting, start by identifying the key processes that can be automated. Pick the easy stuff. Pick the things that are taking a lot of time. Pick the things that are generating the most tickets for you. Start there and start to build that out. And don't be afraid to rethink how those processes work, because there's a really good chance that whatever you're doing now is horrible, right? That you're wasting time, it's not efficient. Also, when you move into an automated fashion, the way it used to work when you did it by hand might not work so well when you do it automatically. So maybe you really need to rethink that. And again, start writing code if you aren't. Any questions? Any comments? Feedback? Feel free to poke away at me. Anybody moving towards the mics? Oh, we do.
Oh, hello, Jared Montz from Akamai. Yeah, I think the title of this talk, I think, is really key, which is having an authoritative source of truth, which is a challenge, I think, for many of us. I know that's been a challenge for me coming over to a new employer in the past couple of years. And I'm wondering what challenges you faced and what things you were able to achieve in having a single source of truth.
This is absolutely fundamental, yes. And as I had mentioned earlier, it is a paradigm shift, not only in yourself, in your team, and eventually in your company. And that's the hard part, for sure. We were lucky that we had a team of individuals that jumped wholeheartedly into DevOps, and we wanted to do it. So we started with the notion that we would create this source of truth with the idea that everyone could use it, but that we weren't going to force people to use it. So we started doing it, and we put all of the network gear in there, and we drove the entire network environment this way. To give you an example of what we did with this, the original environments we were building were several hundred switches, and we were spending about 2 weeks of time with 2 network engineers to build, configure, and deploy that data center. By the end of the project, we were deploying a data center with something like 500 switches, 600 switches, a single engineer, and 4 hours. And that included deploying out the gear, doing all the cable validation, and turning everything over to the compute team. It's your turn now. So again, 2 weeks and 4 hours. Huge difference, right, in the amount of time spent in deploying an environment. Now, of course, that's a greenfield environment, which we don't always get to do every day. But I think the practical aspects of that are the same. Now, how did that actually work as far as getting out the source of truth to everybody? Other people started to see our success, and other teams started using it. The compute team jumped on fairly quickly. Storage eventually came around. And the application layer teams also saw the advantages of it fairly quickly. It was very grassroots, to be honest. We went from just as something we used inside the network team to a company-wide mission-critical tool in about, I'd say about a year and a half. Yeah, and it was literally just like, look at the success we've had. You guys can do this too. Yes?
Hi, Steve Feldman, CBS Interactive. We're going down a similar path. We're using NetBox as our source of truth. We're discovering that works great most of the time, but there are a few cases where NetBox's data models don't really fit what we're doing. So for you or anybody else who's gone down this path, how do you deal with that? Do you use separate databases or tables, or do you try to squeeze it in NetBox somehow?
We custom built our own. At the time that we started, NetBox was not open source and wasn't available. And we had attended several conferences, including Nanog, and heard other companies talking about the automation, and they kind of danced around this topic. But it was clear they must have some form of single source of truth because of the things they're saying. And so, in fact, even I got up to the mic at one point and asked, like, so what are you using for your database? And the answer was, we can't talk about that. It's intellectual property. So we had to build our own at the time, and that's the route we went, yeah. I understand that would be a challenge if you go anything that's off the shelf. Yeah, the disadvantage is that you're going to have to fork it probably if you go this route, and of course forking is always not so great. But you know, we were fortunate to have a database engineer available to us to do this. If I were starting from scratch today and didn't want to use NetBox, I would probably use MongoDB. It's much simpler to wrap your head around, and you don't necessarily have to have a database engineer.
Thanks.
Tony Tobruk, Comcast. I would encourage also people thinking about these things to think about the life cycle of all the things that they do. Like, how do things get in? How do they come out? You know, all the different changes. Because, right, just establishing it is one part, but you've got to think about all those.
I didn't expand into the topic of the orchestration layer as much, but yes, you also need to be able to delete just as well as you add, and you need to be able to change as things change in your environment. For sure, yeah, this is something I didn't delve into, but yes.
Actually, on the change topic, so what do you think, or I don't know if you've had this experience of like, if you change the FQDN, like if you key off FQDN as the, key signifier, identifier, but you may have the same physical box that you changed to a different FQDN because your naming convention changes or something, or what do you find as the thing that you really lock onto? Is it FQDN? Is it some serial number? Is it some just private key that you use for your own purposes?
This is a challenge. On the bootstrapping side, the key that we were working off of was serial number.
Yeah.
So when we bootstrap a piece of equipment, we know particularly who it is or what it should be based on its serial number. That is problematic because you replace the gear and now you've got to go update that. Yes. This is a difficult problem because it's a chicken and egg thing, and how do you flow that out with your intent? Oh, this is really going really deep. If you want to go down the path of intent-based configuration, then ideally it should be, a switch should be able to figure out what it is based on who its neighbors are. So we shouldn't need to know that serial number or that MAC address. At the moment, that is, well, when I left that project, that is still where we were at as far as that. It's a challenge. Yeah. Yes.
Avi Friedman with Kentic. We use NetBox for our old person server huggy thing that you would call a private cloud in Equinix. And then that worked until we started proxying VPC flow logs and being in public cloud, and we're like, And then, as you said, the orchestration system is this other thing, and not talking about what we do for customers, just for our own stuff. So what we wound up with is, for the state of infrastructure and what should be, it's neither NetBox nor sitting in config database. It's sort of mirrored with the orchestration system that links to, is this physical or logical infrastructure? What's the topology? So in essence, we're not really changing the physical state of things that are NetBoxy that much, but all the VLANs and things on top of that, we pushed to a NetBox so an ops person can see it, but we have to write our own. So cloud, which is dynamically orchestrated, and as you were just talking about, the orchestrator itself, where things may be turned on and up and down in containers, but when a ticket comes in and someone says, the thing didn't work at this time, you need to go back and see where it was. Yeah, it'll be interesting. And I have been wondering and asked some people, is NetBox going to go do that? And I've heard there's an endless stream of requests for NetBox anyway, so it'll be interesting to see how that all convolves.
Yes, it's definitely early days on this, particularly I think for NetBox, and it's really cool to hear of multiple stories now of people using NetBox. This is actually the first time that I've given this talk and heard people say, hey, I'm using NetBox. So that's actually really cool. Just out of curiosity, do you guys mind, raise of hands, like how many of you are operating in some form of DevOps automated environment? Like just, is it like half the crowd, more than half the crowd? So like a third of the crowd, something like that? So I hope for those of you that aren't in this environment, give you some ideas for how you can go back and start playing with this today or tomorrow. Sometimes we hear these talks and you're like, oh man, there's no way I could implement that at my place or whatever. But hopefully you can see some path where this is something you can start to implement in your environment, as well as even just for your own future career. I think this is the direction we're heading, right? So, start to learn how to write code. If you're not doing that now, start practicing. Okay, thank you.